Good day to everyone. So in this video, I am going to explain how to write a microcontroller 8051 project in a Keil Microvision-3 software using using Microvision-3 software. So the microcontroller program can be done in the two different aspects. One is you can exactly work with the device, I mean the microcontroller device, or you can emulate the program using the softwares. So the Keil Microvision-3 is the one of the software which is actually used to compile and see the output of the corresponding program like a emulator. Okay, you can just emulate the kit microcontroller kit into a computer based program. So the working environment of the Keil Microvision-3 is actually as like any other Windows software. Like you can see that file. In that file, you can see the creating a new new text files, and also you can open the file and save, and everything is as usual in the whatever the software packages you are already familiar with the Windows. Edit, view, project, debug, flash, and so on. You can see the different command tabs, which is actually take you to the different working environments. So suppose if you want to use this Microvision-3 software to write the program, first always you have to create a project. So if you want to create a project, then you have to go to this project tab, and then you can create a new Microvision project. Or suppose if you have already have a project in the computer, then you open the project using the this open project option. So for the demonstration, I am going to create a new project and how to demonstrate how to write the program. Okay. So once if you click the create new project, it always asks you to save the project first. So you have to give the file name to create a project. So the file name should be related to the whatever the program you are doing. So I always recommend to create a new folder for each project, because suppose if you are writing a project, if you are creating a project, then the supporting files will be created in the directory, so that if you have the multiple projects in the same directory, then it will be confused to you to select the particular project which you have using in the for the future. That means suppose if you want to rerun the project again, then if you open a project, then you cannot able to easily find the project file. So better, I always recommend to create a new folder for the each and every project. Okay, so first one I will writing as a new. So in this new, I'm going to create a project name called demo1. Okay, so the file name is automatically saved as a .uv2, so that you can just click the save file. And once if you save the file, it asks you to take it to the CPU architecture. So you can see the different architecture names here, and Dactyl, Aeroflex, and Altium, and you can see the different names. So each and every name is actually the vendors who are creating the microprocessors. So in this database, you are actually going to use the Atmel, the product of the Atmel processor, which you are going to use for the demonstration for the writing a lab program. So if you go to the Atmel, you can see the different project version. That means different microcontroller versions are available. So you have to choose the specific microcontroller architecture, that is the which we are using is the AT89S51. Okay, so you can see this. So AT89S51 is the chip which we are going to use. So once if you click that corresponding the processor, you can see the description. It's a 8051 based full static CMOS controller with what are the timers and what is the flash memory and the internal memory. Everything will be described here. So you always choose the AT89S51 in the Atmel tab. Okay, so once you select this, and then you can just click OK. It will ask you to add project the setup codes and everything into the project file, which is not needed now because this is only used for the C language. Okay, so you just click no, so that once if you done that, you can see that there is a target file is actually opened, and if you click the target file, you can see the source group. Okay, so in this source group, you have to write the program. and add the program into the source group, so that if you compile the project, then the corresponding file which is related to the program which is available in this source group is actually compiled, and the results will be printed. Okay, so I have created the project. Now I am going to add the I'm going to write the program and then add this program into the source group. So if in order to write a program, you need a text editor. So for that, you have to go to this file and then create a new. So once if you create press the new button, you can see that there is a text editor will be opened here. So this in that text editor, you can write the assemble level program. Okay. Okay, so I start with the simple program where I have to add the two numbers. So the org 0000H, and I'm going to move the number 2 to the accumulator A. Then I have to add the another number with the which is already available in the accumulator, and then I end the program. Okay, so this is the simplest program which will add the two numbers. So I have written this program. Then I have to save this file. So in order to save the file, you can go to the file and then you can click the save. Then it asks you to the it will ask you to save the file. So once if you click the save, it asks you always take the save function to the same directory where you have created the project. So in the same directory of where you have created the project, you can save the corresponding program. So I'm going to give the name, so which should be related to the what the program is actually about. Okay, so I'm going to give the name as adding. Okay, then I have to give the extension. Since we are actually using the assemble level language, so I have to create a program file as a .asm file. So .asm. So .asm is the extension of the corresponding file. So once if you click, give the file name as the file name the extension asm, then you can click the save file. Okay, so once if you save, then the corresponding keywords and numbers will be highlighted in the program itself. Okay, so now we have already created the project, and we have returned the program for the different operations. So now I have to add this program into this corresponding project file, project group. Okay, so in order to do that, I'm going to click the source group, right click the source group, and you can see this add files to the source group. Okay, so once if you click it, it will take to the same directory where you have saved the project file, that is new. So in this you can see this file type as C, but we have written the file program in the .asm assemble level language, so that you just click the arrow mark and you can click choose the ASM source file. So once you click that, then it will also show you the file which you have added in the project. Okay, so adding.asm, just click it and then you have to add it. So once if you add it, the dialog box will not close automatically, so that you have to close manually. So once we close it, then you can see this in the source group. You can see the .adding.asm, the file which the program which we have created is actually connected with the the project. Okay. Now we are ready to run the program. So that means first, in order to run the program, first you have to compile it. The compilation means you have to convert this assembly level language into the machine level language. So in order to do this, you can see this button here. That is nothing but the translate the current file. That is, it actually translate the assembly level language into the machine level language. So once if you click it, then it will convert it. Okay. Then you can just build the target. Click the build target. So once you once you translate the file and then build the target, then you have ready to go. Suppose if you have any errors in this program, it will be shown in this section. So you can see this, the demo one doesn't have any errors. Suppose if you have any errors, then the error will be notified here. Okay, so since this program doesn't have any errors, this will not showing any error for any error. For example, suppose if I left the comma here and if I save the file and if I run the program again, you can see this translate the file. It will show you that there is one error is in the program. That is a syntax error. That is, you are actually it doesn't have the separator for this the line number 2. It also show you the line number as well as the what type of error it is. It is a syntax error. So once if you add the comma and then again save the file, then you have to, once if you troubleshoot the program, then again you have to compile and run the program. So once you compile it, now you can see this, there is no error is present in this program. Then you can build the target. Now we are good to go with the seeing the corresponding output. So in order to see the output of this program, you have to go to this debug and then start the start or stop debug session. So you have to first click this so that it will take you to the debug session where you can see the corresponding registers what are available for the microcontroller R0 to R7, and the accumulators and everything will be shown in this here. So suppose if you run the program here, then the whatever the inputs you have given for the registers and accumulators will be stored here, and then the final values will also the output also you can see it from here itself. So to run the file, you can see the option here. So this option, this button is actually used to run the whole file. That means you can run once you can run it, it will just directly show you the error, show you the corresponding final output, or you can manually run each and every single step. That is, it goes to the step into function. So if you click this command, this button, then each and every line will be manually, compiled, and each and you can see the transfer of numbers to the accumulators, and whatever the operations for the corresponding line will be, you can see it once if you use the press this step into button. Okay, so I always recommend to use this step into button to run the corresponding line, and then you can finally get the output. Because you know how this program is actually working. Once if you use the step into button, the step into option, so you can see that there is an arrow mark here, the yellow color, which is actually showing that at which line which is going to be executed. Suppose if you click the step into program, okay. Suppose if I click the step into once, you can see that the number 2 will be stored in the accumulator. So you can see this number 2 will be stored in the accumulator A, and then the next click, it will add the number 7 to the number 2, and then it again store the same value into the same accumulator A. Okay, so if again click it, you can see that this number will be the number 7 will be added with the previous number, and the final output which actually stored in the accumulator. Okay, that's all. So we have just compiled the program. So even after that, you can, once if you done this, it will show you the disassembly window, which will show you what are the operations you have done in the each and every memory. For example, you can see this, you have you have add the number 2 into the accumulator, and then you can have actually added the number 7 into this A number, whatever the number available in A, then the corresponding operations whatever you have done, it will be shown in the disassembly window. You can just close it so that you can just find you can easily found the output in the accumulator, so that you can write the whatever the output you get in the manual or the record. So you have compiled the program, and you have already run the program and seen the output. Suppose if I want to make any change in the program, then you cannot able to do it here, because the debug session you cannot able to edit the program. You can edit, but it will not be saved. So you should not do the edit operation in this debug session. So if you want to alter the program, then again you have to go to the debug, then you have to stop the debug. So once you stop the debug, then it will automatically take you to the previous working environment, where you can edit the program whatever you require. For example, suppose if I am not giving the numbers into the corresponding accumulator, instead of that I am going to give the memory location, for example 50H and 51H. That means whatever the numbers I am going to give into the memories of 50H and 51H, that will be stored in the A, and then added with the new number which I am going to give in the 51th memory. Okay, that will be stored in the accumulator. Okay, fine. So now I edited the program, so that you have to again compile the program, because this whatever the alteration we have done should be also converted into the machine level language. So I am going to again go into the translate current file, and then the build target. Okay, so once if you done that, and if you confirm that you don't have any errors in the program, then you can again go to this debug and then start debug session. Okay, so so now in this program, we have not given any numbers into the directly given to the accumulator. instead of that, we have given the memory locations of 50H and 51H. So we have to go to the corresponding memory section, memory, and then you have to give the numbers into the memory so that it actually take the memory whatever we have giving in the corresponding memory address 50H and 51H. So in order to give the memory, means you have to open the memory window. So you have to go to the view, and you can see this option called memory window, okay, which will actually already enabled here. So once if it is not available, you can see this. Once you just go to the view and then open the memory view, so you can see the memory, memory options. The memory window is opened here where you can see the address, corresponding address. So you can just give the whatever the corresponding address you have already used, just goes to this address and then click the D colon, then the corresponding address, memory address 50H. Then you can enter you give the enter, and then it will should take you to the corresponding memory line. We can see the values which is already available in the memory window, the memory the memory of the computer. You can see all the everything is 0. So this is 51 and this is 52. Sorry, this is 50 and this is 51. So that is the memory which we are using. So that in the 50 you can going to give the just double click the corresponding memory location. Then you can select choose the whatever the number you have to add with, move to the A. So that I am going to give the number as 5. Then enter. So that the number 5 will be saved in the corresponding memory location and goes to the 51st memory location. Then you can add the another number. For example, I am going to add the 7. Okay. So I am going to given the values of the memories 05 and 07. Okay. So after that, you can directly compile you can run the program again as usual as previously mentioned. For example, if I go into the step into function, and if I click the step into function, then whatever the memory which is whatever the number which is available in this memory 50H will be stored in the accumulator A. For example, if you once click the button, you can see that the number 5 which I have given in the memory location or 550H will be stored in the 05, the accumulator A. Then you have to again click you can see this. Once if I click the first line, then it is actually the arrow mark will move to the next line. That means now this line is going to be executed. So that if you click the button again, you can see this. I have added the number 7 with the number 5. So the final value is the 12. That is a decimal number, but this microcontroller will always convert the decimal number into the hexadecimal numbers. You can see this. The equivalent decimal number of the 12 is actually given as 0C. Okay, so this is how you can use the microcontroller, the Keil Microvision-3 software package to run the simple programs. So similarly, you can once if you completed the program, then you can again go to the debug session, then stop the debug session. So similarly, you can write the programs and then you can compile it using this Microvision-3 software. So I'm going to demonstrate the one more example where you can use the logic analyzer window, where you can create the waveforms and you can visualize the waveforms in the program, in the software itself. Okay. So in order to write the program again, so what I'm going to do is I'm going to close this project and I'm going to open a new project again. So for the new project again, you have to go to this project and then new Microvision. Then again you can create another folder for the corresponding project. So this project I can take the value new one. So in this new one, I am going to give the project name as the demo2. So that is my the next project name. I am saving the project. So once if you save the project, again taking you to the same architecture to select the corresponding architecture. You can just click the ATML and then AT89S51. So AT8S951, you can choose it. Then you can click OK. Then click No. So it will create the target file. Then you can now go with writing the program. So for that you have to again go to the file, then new, then you can whatever the program you require, you have to write the program here. So here I am going to demonstrate you to generate the square wave. For the generate the square wave, I am going to write the assembly level language program. So this is the program which is actually generating the square waves using the short timer option TR0 and everything. So in this program, I have used the pointers P1.0 to for the output, receiving the output. So whatever the wave generated will be given to this pointers P1.0. So I have returned this program. Now I have to save the program. So you can just click the save button, and then you can save the file in the folder which is already available, which is already you have created the project where I have created the. I'm going to write the project file name as square.asm. Okay, so you should always remember to write the extension of the corresponding program file name .asm, then click save. Okay, so once you've done that, you can see that again the keywords will be highlighted. So now once if you complete the program in writing the program and save the program, you have to add this program into this source group. Again, you have to go to the source group, then right click it. Sorry. So right click the software program, then you can add the whatever the program which is available in this folder, you can add the program. Okay, so you have to choose the file type as ASM source file. You can see that square.asm is already given here. So just click it and then add. Then you have to manually close the dialog box. So now you can see that in this source group, the file name which is actually added here. Okay. So once if you done that, you can again compile this program, just translate the current file and then build target. So once you give the translate file, so once you translate the file, you can see that there is no error is presented in the program, so that you can just compile, give the build the target. So once you fill the target, you can go to the debug session and then start the debug. Okay. So this program is actually used to generate the square waves, so that you are not actually going to run the program step by step. Instead of that, you have to run the program with through the you are running the program. So since this program will actually generate in this square waves, so in order to see the square wave of the generated square wave, you have to go to you have to open the logic analyzer window where you have to see the output. Okay, so in order to open it, you have to go to this view and then open the logic analyzer window. Once if you open it, then it is show you the logic analyzer window where you have to first set up the logic analyzer window. So you have to go to setup, then you can choose the what are the corresponding pointer we have added. So you have to add this corresponding pointer. So for this, you have to go this to this new, you click it, then you have to click the P1.0 and then give the enter. So once you've done that, it will add the corresponding pointer into this your working environment, and you can see the display type is bit and then color is given as red. You can choose your own color, and then since we are actually giving the generating the square waves, the variable will actually change with in terms of bit, or you can choose the analog. Suppose if you want to write generate the triangular wave or any other sine wave or whatever the type is, then you can use the analog output. So since you are using the square wave, then the bit is enough. Okay. So once you choose the corresponding parameters in the signal, delay, display, and everything, you can just click the close button. Now, if you run the program again, if you are just run the entire program, just clicking this run button, then it will generate the square waves. So you can see that the square wave is actually generated will be it is actually showing the generated. You continuously the program will run. Suppose if you want to stop the program, then you can click the stop button here, halt button. So once you halt it, the program will be terminated, but the output which will be given is already shown here. So this is the generated output. So if you want to zoom in here, you can go to this zoom option. You can zoom in or you can zoom out, whatever you can do that. So in order to see the square wave clearly, you have to zoom in. Then you can see this is the square wave which you have generated in this using this program. Okay, so you can easily calculate this frequency of this program just zooming in, and you can find me now measuring the wavelength of the single output. Then you can calculate the time period of the output, then you can take the inverse of it, which will give you the frequency. So you can calculate the time period t, then you can find out the 1 by t, which will give you the frequency. So suppose if you take this mouse pointer into the exact point of where the line is actually shifted from 0 to 1, so which will show you the corresponding timing So you can see this the time is actually nearly 7.731 seconds, and then you can note this time, and then if you go to the previous wavelength point, where here you can see the another value. So if you subtract these values, then it will give the time difference between the single wavelength, that means a single or one oscillation, so that you can take the inverse of it, which will give you the frequency, okay, in terms of hertz. So in this way, you can see the output of the any project, any program, like a triangular wave generator, square wave generator, or a sawtooth wave generator. So you can see the wave, the corresponding signal output in a logic analyzer window. Okay. Okay, so that's all for now. So I hope you have get some familiarity about the how to use this Microvision 3 software to write the simple level language microprocessor language programs, and compile it, then see the outputs. Okay. Okay, so and if you have any doubts, then we can while doing the experiment we can discuss about the whatever the doubts you have. Okay, thank you.